The primary structure of the object-oriented programming is a tight connection between data and the functions that directly manipulate them. Specifically, a class is a template for creating a type that contains both data members and methods. Before I move on to talking about how object-oriented programming does it, can you tell me what types you remember? I want people to tell me, in ordinary, regular programming, what types do you remember you have worked with? Can you tell me what types you are used to? Okay, Olarinde says integer type, string type, good. Any other types? Float type, tuple, good. Boolean, float, Boolean, dict, good. Aha, set, list, dictionary, float, good. Okay, good. Good. That's enough. That's enough. Thank you. You see, the strategy of object-oriented programming language is that it turns programming to type making. Instead of just using the types that were given to you by the people who did the Python interpreter, you yourself can now create new types. For instance, you can create a type called student, and that student can have a name, can have a matriculation number, can have grades he has scored in a number of subjects, maybe they have weights, and so many other things. And that student will be a type. So you can now say student Oriola, and then everything pertaining to that student will be there. So it will be a new type. That is the way you can look at object-oriented programming language as a type manufacturing system. So that by the time you finish making your type, the amount of programming that is left is very simple. And that is very efficient in creating more powerful programs. So what we are giving you now, after you have learned once you learn the types and the way to control programming, like you know how a program is run, how it's run line by line, how the simple statements are run on a line, and how the compound statements are run in blocks. If you already know how to loop, you know the looping structures, you know the selection structures, if statement and those blocks. Once you have learned all of those things, you can program anything you like. But if you now add the understanding of object-oriented programming to it, you can now make your own type. As powerful, your own type can be as powerful as the types. Like if you look at the types you are given, they are not more than 10. But an object-oriented programming somebody can create 100 new types. And if you do it that way, you will now be writing your program based on the types you have made. And the libraries that you use are mostly these days written in object-oriented programming way. You're learning the ropes as to how to write object-oriented programming is actually designed to help you be able to navigate your way in type management and type creation. That is really, so just know that you are creating types. All we are doing now is to show you how to create types. So the primary structure of object-oriented programming is a tight connection between data and the functions that directly manipulate them. Specifically, a class is a template for creating a type that contains both data members and methods. Methods are ordinary local class functions that operate on the internal data members. You do not begin to make methods until you already learned how to make functions. You can create global functions that are not attached to any class. If you can do that, you are already used to functions that do not really require any class. Let me see whether the class remembers what functions we have already used. Can you tell me what functions that have been given, that are even in the language that you have been using? What functions have you used before in the programming language? Okay, print, okay, length, okay, okay, integer, okay, that is it. Okay, that's also a function. Yes, string. Okay, so absolute, okay, absolute value, max. Okay, all these functions that you are listing now are called global. Is alpha, which returns a boolean. Append, Okay, all these ones are functions that are predefined, that are given to you. And I'm not sure that Ademola Ikusetu, I'm sorry if I don't pronounce your name right. I don't know whether POP is a global function. I think POP is either local to one list or the other, so that you have to call them in the, it's the built-in, so built-in function. Look, I'm not talking about built-in functions. All the functions you have used, POP, I think, is a method. It's not a function. So the difference between a method and a function is that a method is tied to a type. For instance, the methods that are tied to the list are not ordinary functions. You have to have a list, and you call them by dotting the instance of the list with the name of the function. So let us say you have a list called list one. If you say list one dot something, that is different from print. You can print and just put in the bracket what you want to print. Okay. So all those the things you are typing now are methods. What you are POP is a method rather than a function. A method is a function, but it's a function that is attached and logically linked with another, with a type. So object-oriented programming language allows you and assists you to create methods as well as functions. You can create functions, you can create methods. But when you create a method, it is a function you create in the context of making a class. It is in the context of making a class. So the primary structure of object-oriented programming, OOP, is a tight connection between data and the functions that directly manipulate them. Specifically, a class is a template for creating a type that contains both data members and methods. Methods are ordinarily local class functions that operate on the internal data members. So they are ordinarily local class functions. They are local to the class. What that means, you will see in some example programs that you will see that I will show you subsequently. While the theory is taught, the only way you will be examined is a demonstration of the theory in working programs. I am not going to ask you theory questions most of the time. I may ask you some, but what if you are going to pass this course, you are going to develop a working program. So then your working programs, I care. If it is you used to know the program, fine, it's fine by me, but your program was wrong, okay? It matters little to me that you know these concepts. All I care about is that the concepts come out in working programs that you develop. So I only care about, I see what you know in what you can do with it. In fact, each concept will be demonstrated with programs that work. Understand the code, write your own and make them work. Then you understand the concept. Anything short of that is a waste of time. In our example, every student contains 3 data elements. Your example from the last homework may be different, but the logic is the same. So I gave you a homework to do this before, but I am now giving you my own answer to that. There are local data that pertain to every object instantiated from the student class. So these data members are local data that pertain to every object instantiated from the class. Let us be specific on what we mean by that. For instance, if you create a class called student, well, I'm going to be talking about student, as if that's what we are creating in this class. You can create 100 or 1,000 different classes, but let us just focus on how to create one. We say student class. That's not given in your program. So I introduce that, student class. When we say every student contains 3 data elements. For instance, the data elements can be the name of the student, his matric number, and some other things. So all those ones are local to any object instantiated, to any student. Instantiating the student object is to create a student. So if I create a student, let me see the names of students that luckily for me, I have a name of many students here. Let us say I create a student and the student's name is John Adebiyi. So that is a particular student. So in Jordan DB, we have a name, a matric number, and marks of subject. If another student is Azubuike, we have a name, a matric number, and some grades. If the student's name is Ademola, Ademola will have a name, a matric number, and some subjects. If it's the name of the student is what's that is David Adeleke. Adeleke will have a name, a matric number, and some subjects. So if I tell you that there is a data member, if I tell you that every student contains 3 data elements, those data elements are the things that every student will have values for. The values they have will be specific to the student, but abstractly, they are data elements. For instance, it will be name, but for Azubuike, that name will be holding Azubuike. It can be matric. For Azubuike, it will be Azubuike's matric. It can be grade in a particular subject. For that instance, it will be Azubuike's mark in that subject. So all those ones are called data elements. So every class, when you're creating a class, you create what data elements will belong to every instance of that class. Okay, these are local data that pertain to every object instantiated from the student class. An object instantiated from the student class is a typical student. Azubuike, Ademola, and Kinwade, and so Abigail. All those ones are instances of students. The generic thing, the abstract concept is student. All of them are students. So, but when we talk of instantiation, that is an instance of student is Azubuike. Another instance of student is Abigail. Another instance of student is Adeleke. Another instance of student could be any other student that you can instantiate and give a name to, give a matric number to, and give. So that is how to create the data elements in the class. Now, these objects are the different students created to conform to the general format specified in the student class. The format in which every student must obey that is listed was specified in the class. That is the work the class did, specifying the general format. One thing in this format, as we are saying, is that the elements of matric, name, and a list of 6 courses are common data present for every student. That is how you start. You have matric, name, and a list of 6 courses. We just want to do something simple. Of course, I'm sure you can now begin to see it can become much more complicated, but learn to do the simple one first. If you learn to do the simple one and you do it confidently, it will be easy for you to begin to now expand and do other things with it. It is very practical. Don't forget that object-oriented programming is a model of reality. It's a model of what you actually do. It's a model of what you can actually see in life. So the computer is trying to create a model of reality. So it should be easy. It makes things easier because you are not just thinking it out. It's things you are seeing and you are experiencing on a daily basis. As you can see from the example, there is a method in every class called the dunder init. I say dunder init, that is double underline init. I heard that from somebody who teaches on the web. The init method is not just init. It has double underscore before init and then double underscore after. That method is a special method. And for those who have experience with other programming languages that use object-oriented programming, let us say C# or C++, that is equivalent to what we call constructors in those languages. It is the method that is called to construct and manufacture the specific student. So if you want to manufacture Azubuike now, what will the init method do? The init method will take the template described in the class, and you will see that init method should have, a student should have a matric number. So it will assign a matric number to Azubuike. It knows that a student should have a name. It will assign a name to Azubuike. It knows that a student should have max is 6 subjects. It will pick Azubuike's 6 subjects and it will attach. So by the time it finishes that, after defining the data members for Azubuike, it has created or instantiated that particular student. So every time you try to create Azubike, init method is called. If you want to create Ademola, init method is called. You want to create Abigail, init method is called. You want to create Abandansu, init method is called. You want to create Aruna, init method is called. Each time it is called, it is assigning the specific data values for those particular students to them. And that's one important method that is in every class that we create. It is called the Donda init. That is double underline init. Double underline before, double underline after. When I say Donda, double underline, that is what I mean. Something that has dash dash before, dash dash after. Dash dash is not just dash. It is the underline name dashes, the long underline dashes, 2 on each side. That is the name of the constructor method. And that is one method. It has to bear that name. And it is the method that is a method that will always be in the class, because it is through that method that your particular specific objects are instantiated. When we say instantiate, we mean that if you have a student class, it is the one that creates the particular specific students. Instantiate is what you are doing anytime you attempt to create an object using the template of the student class. Instantiation is accomplished by introducing an identifier into a scope that will reference a new student object. This works similarly to when you introduce any other variable such as built integer, floats, or bool. In fact, note that a class is your power to create new types. So the Donda init method is one method that you'll be knowing more about. In the example here, we perform instantiation in 2 ways: wholesale or one by one. From lines 124 to 132, we are instantiating students as a group, and then in line 134, we are instantiating students. Ukwezilezi Wodo, we are instantiating him as a student, as one student. So you can do it just like you go to the market. You can buy retail or you can buy wholesale. So the instantiation can be done retail, it can also be done wholesale. So you'll see how to do both as we move on. We are going to take this code through a debugger. I hope my own debugger will work, because I had to reboot my computer. I had a working thing before my program froze. But once I'm able to debug, I will take you through the debugger, and that will show you how it's done. Notice that as each instance is created, the Python interpreter makes an invocation of the init method. What is important is that whether you are creating SNew, a student created by name Ukwezilezi Wodo, or you are creating them as a wholesale, every time one is created, the init method will have to be called. You cannot do anything behind the init method. You cannot create. The init method is the creator of instances in every class. It must be called. So it is so important. It is the thing that creates. So even though you can have a student class, it is the init method that creates the students. But it relies on the information in the template of the student class to do that. So it is the one that does the action, but the action is done based on information supplied by the class. This happens no matter how the instance is created. Whether you create wholesale, whether you create any other way, the init method must always be called. In the first case, we created all the necessary data elements for all the 8 students beforehand, and the init simply packages this for each student, and all the data needed to create each one in the list was already known. From lines 134 to 136, we instantiated a new student with the identifier SNew in a completely different way. Here, we did not have the important data elements ready. We invoked a class method called createByName to achieve this result. In createByName, the name of the student is expected, and all the other important data members creating the internal state are given default values. So, for instance, if Donda init wants to create a student, and it only knows it needs the student's name, matriculation number, and grades in 6 subjects. Let us say it only knows by one reason or the other, like in line 134 now. You are creating the student, but you have only supplied its name. What will it then do? It will create Okwezilieze Uwodu. It will give some blank 6 figures for matric. It can be A. So A for matric, because it doesn't know its matric number. For the grades, it can give 0, because that is just initializing. So by the time it reaches line 135, and you are now supplying the matric number, so it will replace the blank matric number it had before with the correct one. Then by the time it gets to line 137, and it knows that you are supplying the grades for that particular student, it will replace the initial values with this. And it will. So that is how it's done. That's how it works. And we will go through an example that is running, and then you see how that is done. And then you can then learn it and then do such things for yourself. Okay. So we have shown just different ways we can instantiate a class, but we can create a class with the complete internal state fully known. In this case, the init is called directly with the data members already defined. We can create a class with full internal data members that constitute the state not fully known. Here, the default values are used to generate internal state, after which the init is used to generate the object. So an object that is generated by init can be fully known and may not be fully known. When it is fully known, everything is ready. When it's not fully known, some things are ready, some things are given some default values, which will later be made good. We can create objects one by one. We can create objects wholesale, like in a list. A list is not the only way to create objects wholesale, but that is one way to do it. No matter how we do it, the init method will have something to do with it and package the internal state of the object. So what does the init method do? It creates the internal state of the object. So ordinarily when your program starts, you know that there can be students. Students can have name, students can have matric number, students can have mark in 6 subjects. But in what does init do? Init says, okay, Okwezilieze is a particular student. Okwezilieze Uwodu is his name. His matric number is SSG215. His mark in the first course is 45. The next course is 56. The next course is 25. The next course is 67, is 88, and 99. See the two. In the first case, the init can create by default values. It can also create by specific final values. It can do both. And you will see how it does both as we move on. Don't forget that the code is fully with you already. It's on the website. I made sure it was uploaded. I mean, if it hasn't been uploaded, I'm sure by the time your class is over, it shall be. So you can take it. The first thing you do, run it. Make sure it is running, and especially run it through a debugger. Understand it. And then you can now begin to play with it. If you do that, then you are understanding, you are learning to program. So don't just take my word for it. If you run it through the debugger, you will see that anytime you are trying to create a student, you see how the computer calls the init method. You will see it called. And I will show it to you as when I get there now. Okay, ordinary methods. We already know that a method is a class local function operating primarily on the data members that constitute the internal state of a class. The internal state of the class is determined when you instantiate the class. You do not have, the student class doesn't have any internal state, but a particular student has an internal state because he has a name, he has matric, and he has subjects. The class itself just knows that there's a name, not a particular name. The internal state is a particular name. The internal state is a particular matric. The internal state is a particular set of numbers that the student has scored in a particular subjects. That is what we mean by the internal state. A type has internal state. Like when you create integer, when you create an integer and you are by assigning a value, that's an internal state. But before that, the integers exist, but this one is particular integer with a value of 7. That is an internal state. So also, when you have a student, the internal state will be the students, all the things that is specified in the class that the student can have. When it has the ones that are specific to that student, the internal state of that has been created. Ordinary methods simply work with the object data. Other methods perform specialized duties, and we shall use examples to illustrate how this work. So there are ordinary methods and there are super methods, and you will need to know how to use both all the types of methods. The init method we have looked at, the dunder method, is really not an ordinary method. It's not a super method, because in most ordinary methods, you are the person that will name the method, but this other one was named for you by Python. So his name has to be dash dash init dash dash. Underscore init underscore or dunder init. The other methods, you are the person that will name the method, but it will be working with the class. This init method is special because its work is to create an instance of the class. The other ordinary methods are used by those instances to do their work. We would, again, these things are difficult to explain, but they are easy to observe when we have used them. Okay, I'm just showing you ordinary methods. What I've been telling you, this is the header of the init, of the dunder init for the class students. It is a function, so it has to start with def, and it ends in the block. So just let us look at this block now. Let's look at this block. This block, as you can see, is a function, and what the function is, it is creating 3 data members, so it has 4. There's the first thing it has to be self. You will see why that is so later on. But what it's really creating is name, matric, and grades. But it has to have that self. There's a reason for that. And then this is where it creates them. It will introduce, it will give it the matric, it will give it the name, and it will give it the grades. So that is that one. Then another method here is call. This call is an interesting thing. It makes your class callable, but that's an advanced idea that I don't want to work on now. Another method here is a class method called create by name. This is what you use to create objects of the class one by one. Okay, and then it will. So this, if you look at this line here is interesting. What this line is telling you is that it will insist that at least you have a name for the student to start with. If you don't have a name for the student, it will not work. But it doesn't insist that you have a matric number. If you don't have a matric number, I want you to go to the chat room and tell me what this method will give as the matric number of the student. Can you go? You might be able to see it immediately. What will it give as the matric number of the student? If you don't tell it, okay, Dixon, you can see that is the default value that will be given. So whether you supply a matric number or not, the student will have a predefined matric number. It's only if you supply one that it will not have it. Now, can you? One other thing I want you to answer. It's supposed to have values for 6 subjects. If you did not give those values, what will it give to those 6 subjects right now? Look at this. It will give each one of them. It will give 0 to each one of them. Okay, so it will give 0, 0, 0, 0, 0, just to instantiate, to start the process up. It will just give them zeros. Okay, good. So that is the work of create by name. And then the next thing that will happen here, the next thing that happens here is property. What is happening here are called getters and setters, and they are known to programmers as syntactic sugar. What is happening from line 17 to line 22 is what programmers call syntactic sugar. Sugar, just sugar, like the one you use to drink your tea. They are completely unnecessary functions, but they are functions that make that. It's just like when you are drinking your tea. You can drink your tea without sugar, but you know, once you put sugar, the tea is sweeter to drink. They make your functions sweet. That is the proper. That is this this ampersand you are seeing here. Is it ampersand? No, not ampersand. This art sign are called decorations. The decorations you see, when you see something decorated like this, that is a special case, special thing. Properties are decorations, okay? So you have those ones. These also are, there are several getters. There are two getters and setter functions there, and they are the syntactic trigger. Then you have some function called name, which you can use to find the name of the student, of particular student. And then average here, this can be used to perform an average on the subjects that the student has. This function here will do the averaging for any particular student. So it is the particular student that you call that will give you the average. You don't give the average for any student. You give the average for a specific student. That let us say you have a student called Nwodo. If you say Nwodo.average, then it will give you Nwodo's average. So that is the code that will be called at that point. This is the print statement here, which we call PRT. Don't confuse this with the printing that you have in your code. This is a method. This is a print method, and you'll see. Okay, so this is the end of the class, and I want to run this code for you to see. I want to run the code for you, and let me first of all stop debugging and start again. This is so I will go and say I will create a breakpoint. Let me see where I can create a breakpoint. I will create a breakpoint where the program really starts at line 102. All the way to line 102, you are just creating classes. You are creating templates for types. This is where the program really starts. Because all the programs before then, all the class definitions before then, they will be used when needed. So before I run this program, let us just see, first of all, I'm creating eight groups of subjects, 8 groups of marks, G1, G2, G3, G4, G5, G6, G7, and G8. The G7 and G8 are not in order. They don't have to be in order. It doesn't matter. Then I'm creating names, Ashubiaru, Juku, Maroko, Shambu, and all those kind of things. And then here on line 126 here, I'm trying to create how many students now? I'm trying to create 1, 2, 3, 4, 5, 6, 7, 8. I'm trying to create 8 students. 5 of the students will be created from the student class, and 3 of them will be created from inherited classes. So an engineering student, or a medical student, or an athletic student, which is a special student, which are special students. So the first student is a normal student, the second student is a normal student, the third student is a normal student, the fourth is a normal student, but the 5th will be an engineering student. That is special. So it has everything about engineering, but it's where he's doing his IT. Then the next one is a medical student. It has everything about student. It has the name, it has the matric number, it has the marks in subject, but where it's doing is surgery, is where it's doing the industrial attachment. I don't know what medical people call it. So he's doing this surgery. Then an athletic student is also an ordinary student, but where he's what sport he's playing, badminton. You can see that they are more than this. So you will see how we create a student, and we'll see how we inherit all the attributes of student and then add something to it to make an engineering student. All of that is here.